Alright, so we're going to start by going to the data sheet. There's a lot of things that are useful in this data sheet, and I don't want to make you start hating lots of information in data sheets, but there's a lot here that actually makes sense. The reason why you get 256 colors per LED, so each of these Neopixels, they're called Neopixels, or also we call them addressable LEDs, because you can address each LED basically, not individually, but like a cascading format. Each LED, and I'm talking about the inside LED, there's 3 of them, RGB, red, green, blue, and between those you can mix the colors and change the brightnesses and get almost any color you want. So 256 we're going to look at right now, so we'll go down here. So there's 256 brightnesses, and 256 is your maximum brightness, okay, that you could send to it. But actually the number is 255 in decimal. And because they consider the first brightness as being off, okay? And so this is actually what's being sent, this string is actually what's being sent to each LED. And we're going to look at, so you can't just send 256 or 255, or if I wanted to turn on to 50, you can't just send that in decimal. Like, the computer doesn't do numbers like we do. And also, 255 is actually your highest brightness you can get. And then you can get any integer number between there. But in order to send an integer, or 50, or like any number you want, and we're going to send actually 1, so just the lowest light setting you can possibly send. You have to send, these are the different positions each number can be sent. So, like I said, we can't send decimals, so we have to send 1s and 0s because it's a digital system. And to get the lowest brightness, you'd send a 1 in this spot and 0s in all the rest. And that's going to come out to be just 1. Now, if you were to put just a 1 here and nothing else in all these, for green, it would be sending a 2 because it's binary. It's in binary, a 1 in the second place. The bigger the digit, obviously, the same number, but the bigger the digit and the bigger the spot, the more significant it is. So this is how it's being sent, and so it sends B0 first. So if it's in B0 and then send all zeros for the rest, you get 1 blue, barely on. Likewise for red, if you sent 1 in the 0 red spot, you get just barely red being on. So we're going to do that. We're actually going to send this, and I've got what's called a logic analyzer, and we're going to actually just see the numbers scrolling by, the 1s and 0s, and these are pulses. And so to look at the pulse diagram, so we go up here, this isn't that complicated. To send a 1, this is what you need to send. You need to send time for a 1, this is T1, high, and there's a chart up here, and then this is going to be time for low, and there's another time. And then for 0s, you send an opposite pulse, which is shorter on time and longer off time. Let's go up to the timing table. So it's kind of I wish they organize this better as well, because time 0 high, time 1 high. I'd almost rather have time 0 high and time 0 low right next to each other just to make it easy. But these are the different timing, and then there's a plus or minus 150 nanoseconds. 150 nanoseconds is 0.15 microseconds. So you can do, like I said, you can do 2.5 microseconds is in spec of this, or 5.5 microseconds would be in spec of this. So what they're saying is you can have this pulse, the width can change a little bit and the thing will still work, because you're never going to get your timing absolutely perfect. So there's a window of time there. So what I'm going to do is I'm going to go and get this. This is the analyzer I was talking about, and basically allows you to see the pulses being sent. So I'm going to go all the way down here, and I'm going to delete the data before this point, and then we're going to start it, and then I'm going to hit the reset button to send 1 pulse on the Arduino. It's going to reset the Arduino, sends a pulse. We didn't even see it. Like, did you see anything? Nothing. But if we go and zoom out, and then we hit this little thing, go to the next edge, we can see there's a bunch of stuff here. And from out here, like, what is that? Just like a little blip. But if we zoom in, all right. Now what I was trying to send, so going back to the data sheet, I was trying to send 1, 1 in the, not like the ones place, right here, 1, 1. And everything else should be 0. So we should see a lot of these pulses, a lot of T0s, a lot of these pulses, and not very many, and only 1 pulse that has a longer time on. So just quickly looking at it, I see it looks kind of right. Like, you've got a lot of skinny pulses here. And, oh, we got something different going here. So if you zoom in a little bit more, these are all supposed to be 0 pulses. And for a 0 pulse, we said 4 microseconds. Well, right here is 2.5 nanoseconds, which is, 2.5 microseconds. Well, that is within spec because, like we said, it's supposed to be 0.4 microseconds, sorry, and it is 2.4 microseconds. And but remember the 150, so right here, the 150 that was allowed, 150 right here, this is 0.15 microseconds. So basically, it is within tolerance. If you scroll over here, so this would be your first, this would be G7, G6, G5. So then these are zeros, as we confirmed, G4, G3, G2, G1, G0. So that's exactly what expected. And as you can see on the camera, it actually did light up. Well, the LED, and I'm going to change it to be then, we'll send just a 1 for red. Just barely turn the red on, just so you can see that this is working. It wasn't previously on. Like, I can actually quick unplug this, plug it back in, turn the microcontroller on, and turns the green on. We're going to do the same thing with red. So I'm going to zoom out, delete the data before this point. We'll start that up. We're going to pull the Arduino code up. Right now I have it set to turn on 1, and this is RGB. Now the actual string of data comes in the other sequence. But so I'm gonna turn this, and then we're gonna set the red on, just 1. We're gonna send this thing over. You'll see it update. Okay, so you saw it updated on the screen. And now we're gonna pause this, go to the previous edge. Oh. So we saw these are all zeros, so G7, G6, G5, G4, G3, G2, G1, G0, red 7, R6, R5, R4, R3, R2, R1, R0. So just what we expected. And actually, there's some other data over here, and that's my fault, because on the Arduino code, it's set up for 2 LEDs right now. So it's actually trying to turn 2 LEDs on. Now, if you don't do anything for the other LEDs, it just sets them all to 0. If I put like 20 LEDs on here, I'm gonna go back to here. You start running this thing, and you stop. And we go back to all the data. You'll see I have all these LEDs on, all this more data, right? And what you can see is this 3 is for LED 3, LED 2, LED 1, LED 0. And that's why they call it addressable, is you can, basically control each LED separately if you want to. So you see it's all the way down to LED 19, LED 19, which is really LED 20 since we started at, if you start counting at 0 as your first one, then you're going to total when we actually have 20. But in engineering, you start at 0. So that's all I have for today. Really, this is a neat tool to quickly look at, like, okay, this is what's being sent. Here, quickly shows you that. You zoom in, LED 0. For green, it's a 1. Or sorry, for red it's a 1, for green it's 0, and blue it's a 0. And then you actually see the number that's being sent in hex. This isn't that hard. Like, you can do this. You can get a logic analyzer. Anyway, that's all I have for today. And thanks for watching.